Hello, students. Welcome back. Today we'll be looking at enzymes. Enzymes are proteins that function as biological catalysts. Catalysts speed up reactions without themselves being changed by the reaction. For an enzyme to work, there has to be a substrate and a product. The molecules that react in the enzyme catalyzed by reaction are called substrates, while the molecules that result are called products. Enzymes are specific. They work on one kind of substrate only. For example, proteases break down proteins but have no effect on carbohydrates and lipids. This results from a fit of the active site and the substrate. A diagrammatic representation is shown, showing the active site and the fit, how it fits into this, how the substrate fits into the active site. The mechanism of enzyme action. The enzyme is a protein, like we have said before. It is folded into a complex three-dimensional shape. The active site is the part that allows it to act as a catalyst. The enzyme molecule binds with substrate molecules. This can happen as many times as possible, not just once. Substrate molecules fit exactly into the active site of the enzyme to form an enzyme substrate complex. The substrate now reacts to form a molecule of product which leaves the active site. Now, a quick question. An enzyme molecule can bind with a substrate molecule only once. True or false? False. Factors affecting enzyme activity. The first factor we have here is temperature. A high temperature speeds up the movement of substrate molecules but can easily denature an enzyme. Every enzyme has an optimum temperature limit. Every enzyme has an optimum pH limit as well. For example, pepsin works in the stomach at pH 2, very acidic, whereas amylase works in the mouth at pH 7.5, slightly basic. Activators. Activators make enzyme binding with substrates more likely, e.g., chloride ions and salivary amylase. In this case, the chloride ions serve as the activator. Inhibitors make enzyme binding with substrates less likely. Example, cyanide ions block the active sites of enzymes involved in respiration. Uses of enzymes. There are several uses of enzymes. We have found some of their uses in pharmaceuticals. The enzyme catalyst is used in wound dressings. Catalyst converts hydrogen peroxide in the dressing to oxygen and water. Oxygen speeds up healing. In food production, lipase from fungi helps make chocolate flow to cover biscuits and sweets. Protease from bacteria softens gluten in rolling of biscuits. Pectinase breaks down clumps of plant cells, which changes fruit juice from cloudy to clear. Washing powders. Washing powders that contain lipase and protease are used to remove difficult lipid stains from fatty foods on clothes. I have some activities laid out for us, some of which are past questions, Cambridge past questions. Which type of molecule are enzymes made of? Enzymes are made of protein. Correct. Which statement describes a catalyst? It decreases the rate of chemical reaction and is not changed by the reaction? No. It increases the rate of chemical reaction and is changed by the reaction? No. It decreases the rate of chemical reaction and is changed by the reaction? No. It decreases the rate of chemical reaction and is not changed by the reaction. Correct. What controls the speed of chemical reactions in all living cells? Enzymes. Which statement about an enzyme controlled reaction is correct? The enzyme is slowly broken down during the reaction. No. During the reaction, the substrate changes to product. That's most likely the answer. But let's check the other options. The higher the temperature, the slower the reaction. No. The enzyme is gradually used in the reaction. No. So go with this. Correct. Which statement correctly identifies the enzyme and the products of fat digestion? Fats are digested by the enzyme lipase to form fatty acids and glycerol. Correct. So that'll be all for now. Thanks for your time. Remember to check us out on our website www.edubbey.com.